This lesson is going to be looking at interior and exterior angles of polygons. So in order to find the sum or the total of the interior angles, you need to connect the vertices. We already know that a triangle has the three angles together that equal 180 degrees. So when you're doing it with another polygon, you can start by connecting the vertices. So what I do is I personally pick a corner or a vertex, and I make sure it's connected to all the other ones. It's already connected to this one, so I don't need to draw a line there. It's already connected to this one, so I need to draw a line connecting it. But if I look here at this third one down here, there's not a direct line connecting it, so I'm going to draw a direct line connecting it. Now by doing that, I created 1 and 2 triangles. And we know that each of the three angles in a triangle adds up to 180 degrees. So for a quadrilateral, a four-sided figure, I can take the 180 degrees and multiply it by 2 because I created 2 triangles by doing that. So in a quadrilateral or a four-sided polygon, the angles together add up to make 360 degrees. I could do the same thing for the pentagon and the hexagon. I pick a corner, again it does not matter which corner, and I connect it to the ones that it's already not connected to. It's already connected there, so then I have to draw a line down here, connect it to that one. The next one it's not connected to as well, and then this third one's already connected. So this time it makes 1, 2, 3 triangles, and each triangle is 180 degrees, so 180 times 3 in a pentagon or a five-sided polygon, there is 540 degrees when you add all 5 of the angles together. And then the last one in the picture is a hexagon, a six-sided figure. So you pick a vertex or a corner, doesn't matter which one. It's already connected up here. It's not here, so I need a line here. It's not to the next one, so I need a line there. It's not to the next one, so I need a line there. And then it's already connected to that one. So this time I made 1, 2, 3, 4 triangles. So I multiplied 4 by 180 to get 720 degrees of the interior angles of a hexagon. So this time we're looking at a table, and it tells you some things. It tells you the number of sides the figure has for the quadrilateral, the triangle, the pentagon, and the hexagon, and then the number of triangles created by connecting the vertices, and then the total number of degrees. There is a pattern here. Instead of having to necessarily draw those triangles and connect the vertices every single time, there is a pattern in these 2 lines of the table. If you're looking at the number of sides compared to the number of triangles, you should see the number of sides is always 2 more than the number of triangles. So to figure out this section, the number of triangles, you can take the number of sides and subtract 2, and that will always give you the number of triangles, which then you can take and multiply it by the 180 degrees, because again, each triangle is 180 degrees when you add all 3 of their angles together. So if we're looking at an exterior angle, it says, is formed by extending the sides of one of the polygons. So if I take this bottom side and I extend it, make it further, this here, this space, is an exterior angle to that triangle. And it tells you to use the concept of supplementary angles to determine the exterior angle measure. Remember, supplementary angles are angles that when you add them together make 180 degrees. So that angle that I just marked in red is supplementary, or is next to, right, that angle, or the exterior angle to the 70-degree angle. Supplementary angles make 180 degrees. I already used 70, so I can subtract to get 110 to figure out what the exterior angle is. So to figure out what exterior angles are, if you extend each side of the polygon, they're always supplementary with the angle that is right next to it. So to find out what the degrees of each exterior angle is, you can take its value and subtract it from 180 degrees, as you see the work in this picture, and it gives you the value of the exterior angle as compared to the interior angle that it's next to.